Hi guys, welcome to the April 2022 Solar Energy Off-Grid Utilization Data Analysis. This is my data sheet and my raw data is here. Now, do not worry so much about these blue columns here. The reason why I take this data is because I bought a chat controller that comes with its own watt meter. So this is for my blue screen watt meter. If you have seen the image of the video of my distribution board, you will notice that I've got each of the chat controllers have their own uh, blue screen watt meter. Uh, Two of the chat controllers comes with their own inbuilt watt meter, so I'm just collecting the data together so that I can use it to feed back to the manufacturer. As you can see, they are not usually accurate, both of them. There's something not right there, so I would just normally use that to feedback. So let's go into uh, analysis here. So for now, we're going to ignore the raw data because what happens here is that I would combine the watt meter for each of the arrays, and that will give me the total watt hour generated for that for the day and also for the month. So the total watt hour generated for the month of April was 260 kilowatt hour. That's 260,032.6 watt hour. But if you divide it by 1000, it will give you the kilowatt hour. So in this case, it's going to be 260 kilowatt hour. Now I have my usage, so you will notice that I have a blue screen energy meter that gives me the AC usage, what I'm using out of the watt hour generated on a daily basis. On this date, 1st of April, I generated around 8 kilowatt. I used 5.6 kilowatt out of that. On the second, I generated around 8.4 kilowatt, and my usage was around 6.1. So if you look at for that month until month to date until 30th of April, I've used 185.7 kilowatt hour out of 260. And also you can see this graph here. It gives some quite a quick update in regards to everything you can see here. So if you don't want to relate with all this raw data, you can just look at the graph and you can see on this date, I think 18th of April was the highest for the month of April, where I exceeded around 12. I got around 12 kilowatt hour, and two other days happens to be one of the best. So you can see 11th here, 11.8 kilowatt hour, and also on the 21st. So on the 21st and on the 30th, they were pretty good as well. And on the 18th was actually the highest in the month of April. Now we're already 2 days into the month of May, and as you can see, I've only been around that 7 kilowatt hour. I think things are just gonna get better as time goes on, and you can see my usage on a daily basis. So was for yesterday, and so yeah, and this is for today so far. Now let's go back to April because we're going to be centering this conversation, this analysis into the month of April. And what I want to point out here is the fact that, okay, so I have generated 260 kilowatt hour of solar energy, but I've only been able to use 185.7 kilowatt hour out of it. Now, where's the rest of the energy? Now, this is what I want to discuss today. I think I have a fairly good understanding of where the remaining energy must have gone. So the first one I would normally look at here would be the inverter. So the inverter itself requires energy to run. So on the standby, let's say I turn on the inverter and there's no load on it. The inverter to run use 2.6 amps basically to run. Now, let's do some little calculation here. So 2.6 amps to run. I need to know how much voltage that is. Now, because I have 24 volt battery system, I need to multiply that by 24, and that will give me my watts, the watt energy that I'm using, that the inverter is using. So that's 62.4 watt hour. So every hour it will use around that 62.4. And in a day, my inverter will be on. As you can see, it's been a very good month in the month of April. So in a day, my inverter will be on for roughly 12 to 14 hours, but I will just bring it down to that approximately to 12 hours, basically. Yeah, just to make sure we're getting accurate figure here. So 64, 62.4 times 12 hours. So we've got 700 and 748 or 749 approximately watt hour in a day that I'm using out of that the inverter is using on its own in a day. So if we multiply that by 30 days, which we have 30 days in the month of April, so that will be times 30. That gives me around 22.5 kilowatt hour. So we need to add 22.5 kilowatt hour, 22.5 kilowatt hour plus 185.7. So the 185 is this, the total usage in the month of April, the one that I consume myself, not the one that the inverter. So if we add in one of the inverter, we got 208.2 kilowatt hour. So if we minus this by the total solar energy generated, now we have 51.8 kilowatt hour lost. Where has this gone? We need to know where exactly. How do we account for this? We've been able to account for some part of it, which is, some percentage, which is the one for the inverter. Now we need to know where this 51.8 kilowatt hour has gone. This is quite a lot of energy. You can just let it go like that. Now, the other things that I would normally use to account for this 51.8 kilowatt, one of them is the conversion ratio. So what normally happen is when you convert solar energy, your solar panels accept that and convert it into electrical energy. The electrical energy travels through your solar charge controllers and goes into your battery. So in that case, you're converting solar energy into electrical energy through your solar panel, and the solar panel transfer that electrical energy into a chemical energy which is in your battery. Now when you save something into your battery in form of chemical energy, the conversion ratio into AC is not always 100%. So there will be some energy loss in the process. Remember what you're doing is, in my case, I am inverting a 24-volt system into 230, 240 volts. That process requires quite a lot of energy to convert a 12-volt system into 240 volts, basically. And what normally happens is, let's say you have like 1000 watts of AC appliance. Uh, on a 24-volt battery bank. So what normally happen is you need to multiply or you need to divide your 1000 watts AC appliance by the 24-volt battery bank system. That will tells you how many amps is going to be required from your battery bank to feed that 1000 watts AC appliance. Now, let's just quickly go back into the energy loss. So when you are inverting the 24-volt battery DC into 230, 240 volt system, that requires a lot of energy. So definitely you would lose a lot of energy in that process. Thirdly, um, we've looked at the inverter taking up some energy. We've looked at the inversion process at 24 volts into 240, 230, 240 volts. The third thing that I would normally look at here is the fact that your battery holds the best charge when um, when it hits or when it meets the standard testing condition, which is most often 25 degrees centigrade. That is, or Celsius, 25 degrees Celsius. That is when your battery hold the best charge. Now, when the weather is too cold or too hot, your battery would not perform at its best. You will not get the best of, it will not be able to retain a very good charge when it is too cold and too hot, except when you hit that, you know, that temperature level. So these are the three things that I would normally look at when I'm trying to account for the rest of the energy loss, basically. Now, let's go back. I hope that actually clarifies this. If you have more information you want to share with me in regards to this, or if I miss out anything, you can always write in the comment below or just message me directly, however you want to do it. Or I think if you put it in the comment section below, I will definitely see it and give you my own reply. Now let's go back into March here. So as you can see in March, I generated 163.4 kilowatt hour, but I was able to use 113.5 kilowatts. I can also do the calculation by adding the energy usage from the inverter itself. So if I add it, it's going to be giving me around the same figure as to what I get in April. So if you want to do that calculation, please go ahead. But it's somewhere around that. I don't want to take up much of your time in trying to to do that calculation right now. In April, you can see this was when I installed my energy meter. If you go back into some of my videos that I've made, you will see my energy meter that I installed. And so I installed it on this date and I started collecting that data. No, I actually installed it on the 1st of April, on the 1st of February, but I did not start to take the reading, the daily reading until this date. So um, that's just what I want to share in terms of April, in terms of February. So as you can see in February, I generated 84.6 kilowatt hour and I was only able to use 53.1. If you add the one from the inverter consumption itself, that will go up a little bit more. And in January, I generated 45.5 and I was only able to use I would at this point I've not installed the energy meter, so you can also do that calculation of what you expect because I would say I use between that 62 to 72 percent of the energy usage. And let's go back to December 2021. This is not the best month when it comes to solar energy. As you can see, I only generated around 22.8 kilowatt hour. So definitely I wouldn't have used more than 62 to 72% of that. And November, if you look at the chart here, you will see that that is when we started to I started to notice decline in solar energy being generated. As you can see, it was just coming down. And here also I generated 70, 47.5, and I'm sure I would have used something between that 62 to 72% of this energy. And in April, sorry, in February, you can see the trend line. It was trending up. That is when the solar became, it was the sun was becoming, was coming out more, less overcast from February. Actually, it was from January. If you look at it from January as well, look at the trend line, it was just kind of going up. And I think the highest in that month was around 3 kilowatt, basically. 3 kilowatt, 3.4 kilowatt. And in February, I was able to generate about 7 kilowatt in one of the days, 27th of April. And you can see it was actually upward trend as well. In March, and I started hitting around 8 kilowatt hour a day. As you can see, the trend line is actually going up as well. And in April, it was more consistent. You can see there are more better days than there are bad days when it comes to solar energy. And even the worst day, I was still generating around 4 kilowatt hours. And yeah, May it's not been really great, but if you can still look at it, it's still going up to 7 kilowatt hour a day. And I've already used 9.6 kilowatt out of 14.6 kilowatt generated from the solar panel. I've been able to use this. So that is just my breakdown. As I said, if you think I've missed out something or if you have some suggestion, please put it in the comment below. I will definitely respond to you guys. Thank you guys for listening. Please subscribe to my channel and you have a great day. Bye bye.